Hello everyone. Welcome back to this lecture series on structural mechanics. In the previous lecture, we studied the analysis of trusses using the method of joints, where we determined the forces in all members by satisfying the equilibrium at each joint. In today's lecture, we will study another powerful and efficient method of truss analysis known as the method of sections. So this method is particularly useful when we are interested in finding the forces in only a few specific members rather than in the entire truss. So the method of sections is based on a very fundamental principle of mechanics, that is, a truss that is in equilibrium will remain in equilibrium even after it is cut into two parts. Right. That means if you pass an imaginary section anywhere in the truss and isolate one portion, that is the left portion, if you are isolating, that portion must still satisfy the conditions of equilibrium. Even though if it has been cut also, that portion remains the equilibrium condition. That is what is the principle which lies in the truss analysis and to specifically in the method of sections. So the key difference from the method of joints is, in method of joints, equilibrium at each joint being considered, whereas in method of sections, equilibrium of part of a truss will be considered. Now let us understand the principle more clearly. When an imaginary section cuts through a truss, the internal forces in the cut members are exposed. For example, if I are cutting through this one, in the sense this member, and this member has been cut through this the imaginary section. So therefore, the internal forces of these three members been exposed, and these internal forces acts on an isolated part, and the isolated portion behaves like a free body, thereby applying the equilibrium equations to solve for these three forces. See, the one restriction is that the section, whatever we are assuming to pass through the truss members, should pass through not more than three unknown member forces. It should not pass through more than three unknown member forces. Why means? Because we have only three independent equilibrium condition, that is summation fx equal to 0, summation fi equal to 0, and summation m is equal to 0. So in that case, the section can pass through a maximum of three members only. So the general steps involved in the method of sections is: check the static determinacy first, pass an imaginary section through the truss cutting at most three unknown members, isolate one side, either the left side or the right side, draw the free body diagram of the isolated part, apply the equilibrium equations to find the required member forces. So the method of sections is especially suitable when forces are required in only a few members, not the entire trusses. And the truss is large as well as complex, like this case. So using the method of joints would be time consuming to find the forces in specific members in case if the structure is very complex. So engineers often use the method of sections to quickly check the forces in critical members, such as those near the midspan or the supports. Now let us go with the numerical example. Let me start with a truss in which two forces are acting. You are supposed to find the forces in the member CD and DF. That is, CD is this member, this is the first member, and DF is the second member. See, whatever the question, whether we are going to find the forces in a single member or a multiple members or for the entire trusses, first step is we need to check whether the truss is a perfect truss or not. Right. So for which we need to find the number of members, the number of joints, and the number of reaction components. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17 members are there. Regarding the joints, we have 1, 2, 3, 4, 5 on top, 5 on bottom. So 10 joints will be there. And here we have a pinned support. We'll have the vertical reaction and the horizontal reaction. Here a roller support will have only vertical reaction. So totally 3 reaction components will be there. Now substituting in this one, m plus r is equal to 2j. Here m is 17, r is 3. So it will come 20. On the other side, 2j, 2 into 10 will give 20. So both sides are equated. Therefore, the given truss is a perfect truss. Second step is we need to find the support reactions. As already mentioned, there is a pinned support will have two support reactions, one in the vertical direction and the other one in the horizontal direction. Whereas in the roller support, we'll have only the vertical reaction. Right. So applying the equilibrium conditions for the entire truss, that is Fx equal to 0, we don't have any forces other than this HB acting in the horizontal direction. Therefore, HB is equal to 0. Next, applying the vertical force equilibrium, we have VB and VJ are acting in the upward direction, whereas this 12 and 12 are acting in the downward directions. So applying that one, VB plus VJ minus 12 is equal to 0. There comes the equation VB plus VJ is equal to 24. Next, we have only this relationship between this VB and VJ, but we need to calculate the value of VB and VJ, for which we can apply the third equilibrium condition, that is the moment is equal to 0. As the truss members are connected through frictionless pins, all the joints, the moment can be equated to 0. For our conveniency, we are taking with respect to the support. MB is equal to 0. In that case, we have VJ. VJ will create an anti-clockwise moment about the point B, and that value will be equal to VL into the VJ into the perpendicular distance between the J point and the B point is 9.6. This is what the moment which will be created by this VJ. Next, 12 kilonewton. This one, the line of action is going in this way. So if I'm rotating this force about the point B, means it tends to rotate in this direction. That is a clockwise direction. So that will be negative. So minus 12 into the perpendicular distances from the point E to B. So this is what is the perpendicular distance. That is nothing like 2.4 plus 2.4. It will be 4.8. Next, moving on with this 12 kilonewton force, again, the line of action is not passing through the point B. So it tends to rotate about the point B in the clockwise direction. Again, that is also negative. So minus 12 into, now the perpendicular distances from point G to point A or B. Both are in the same line. That is nothing like 2.4, 2.4, 2.4. Right. So in that case, you may be getting that value will 7.2. That's it. That's what has been shown here. VJ into 9.6 minus 12 into 7.2 minus 12 into 4.8, which will be equal to 0. So solving this equation, we'll get the value of VJ as 15 kilonewton. Substituting the value of VJ in this equation, we'll get the VB as 9 kilonewton. Now we got these support reactions. That's what has been written here. And HB is 0, so that has been removed. Now the question is, we need to find the force in this member as well as in this member. As per the principle, we are going to introduce an imaginary section that should pass through these two sections. Right. So it can be any direction. It can be horizontal or vertical or inclined or even any bends. The section can be drawn in such a way that the section should pass through these two members first. And it can pass through a maximum of 3 members. So in that case, let me assume the section is passing through in this direction, which pass through the CD as well as DF. But you can see that it is also passing through the member AC. That is not the point of interest for our case. Right. So now we can see the left portion has been isolated. The left portion of this section has been isolated. That's what has been shown here. The broken 3 members, that is AC, DC as well as DF. The broken 3 members has been given. And also the left side we have this support reaction is there. That is also been shown. Now, introducing the forces in this broken members, that is the internal forces being exposed in those members. Let me assume all the forces are in tension. So FAC, here FDC and FDF. You can see all are taken away from the joint, that is we are assuming the members are in tension. Now, this is coming under the non-concurrent force system because forces are not acting at the same point. Whereas in case of method of joints, all the forces will act at the same point. That's why we applied only Fx equal to 0 and Fy equal to 0. But in this case, in addition to this two equations, since the forces are acting at a different points, we have M is equal to 0 also at all the joints. That's what we are going to apply. Let me go with the vertical force equilibrium, that is Fy equal to 0. We have 1 and 2. These two are acting in the vertical direction. So both are acting in the same direction upward. So 9 plus FDC is equal to 0. Solving, we'll get FDC is equal to minus 9 kilonewton, which means that our assumed direction is wrong. So this is wrong. So it has to be acting in the downward direction. That is nothing like this member, that is CD member, will be in compression. Okay. So that is what FDC is equal to 9 kilonewton compression. Next, let me go with the horizontal force equilibrium. In that case, we have FAC is there, FDF is there. These are the two which are available. So FDF plus FAC is equal to 0. Right. Since both are unknown, we can't able to solve for this one using this equation. Let me go with the third equilibrium condition. As I told, all the joints in the trusses are connected by means of frictionless pins. So you can assume moment is equal to 0 at any point. So here I assumed the moment is equal to 0 at point B. Even the same can be assumed for point A or point D also. Right. So if I am taking with the point B, this will not create any moment, as well as this FDF also will not create any moment, because the line of action is passing through the point. So this also will not create any moment. Only these two will create a moment. Now moving on with this FAC, the force is acting in this direction. So if I am rotating this force about the point B, it tends to rotate in the clockwise direction about the point B. So that will give a negative moment. That value will be minus FAC into the vertical distance between AB. That is this one, which is being given as 1.8. So 1.8. Next, we have this FDC. FDC is acting on the right side upward. So it tends to rotate in the anti-clockwise direction about the point B. So it will create a positive moment. That value will be equal to FDC into horizontal distance between B and D. That is B and D, which is nothing like 2.4. That's it. So these two only should be taken into account. So minus FAC into 1.8 and FDC into 2.4, which will be equal to 0. In which FDC has been already calculated, which is minus 9. So substituting the value of FDC as minus 9, we will get the value of FAC as minus 12 kilonewton. Again, you can see this is also the assumed direction is wrong. So this will be wrong. It will be in compression mode. This is also compression. Right. So FAC will be equal to 12 kilonewton compression. Now, substituting the value of FAC in this equation, that is minus 12, we'll get FDF is equal to 12 kilonewton. That is positive value you'll be getting, which means the assumed direction is correct, which is in tension. So this is in tension. So these two members only been asked. So that is FCD and FDF. So FCD is 9 kilonewton, which is compression, and FDF is 12 kilonewton, which is in tension. These two have been only asked. Now you can see that in case of method of joints, we will be going with each and every joint in order to solve for the member forces. But if the specific member has been asked, rather than going with the method of joints, we can use the method of sections in a simplified manner. Next, let us move with another example wherein 3 members been asked to find out. That is AD, this is one member, and then we have CD, the second member, and CE, we have the third member. So if that is the case, and one more thing here, it doesn't mean that we need to draw an imaginary section only once. For example, if the question is you need to find the forces in more than 3 members, in the sense, as per the assumption, the section can pass through a maximum of 3 members only. In that case, we can assume 2 sections separately and solve for it separate methodology. So now, as always, starting with the analysis, we need to check whether the truss is a perfect truss or not. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, this is 16, 17, 18 and 19 members are there. Right. So you may think that that we need to consider this as a separate member in the sense, since this joint has been taken into account, so this has to be taken separately. Right. So we have 19 members are there. Coming on to the joint, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 joints are there. So that is what has been given here. So M is equal to 19, joint is equal to 11. And you can see that this is a roller support, we will have only vertical reaction. And this is a pinned support, we will have vertical reaction as well as horizontal reaction. So 3 will be there. So r is equal to 3. Now substituting this one, we have m plus r is equal to 2j. That is here 19 plus 3, which will be equal to 22. In this case, 2 into 11, which is also 22. So both sides are equator. Therefore, the given truss is a perfect truss. Now the second step is we need to find the support reactions. Since roller support is having vertical and hinged support will have both vertical and horizontal, let me assume in this directions, right? So applying the equilibrium equations, that is Fx equal to 0. If so, we have this is horizontal force and this is the horizontal reaction. That is Hk minus 36, which will be equal to 0. Therefore, Hk is equal to 36 kilonewton. Now applying the vertical force equilibrium, we have Vb and Vk both are acting in the upward direction, and this 20 and 20 are acting in the downward direction. So Vb plus Vk minus 20 minus 20, which will be equal to 0. Right. So Vb plus Vk is equal to 40. Now one more thing, you can see that the structure is very symmetric and the vertical loads is also symmetric. Don't take it directly as Vb is equal to 20 and Vk is equal to 20, because in addition to these two forces, we have this 36 kilonewton is also acting, which makes the structure not an symmetric one with respect to the forces. So directly we can't solve for Vb and Vk. We need to apply the equilibrium equations. Right. Next, we shall move with the moment equilibrium condition. Applying moment at B is equal to 0. We have this Hk will not be creating moment because the line of action will be passing through that point, so it won't create any moment. Whereas Vk will create a moment. So that will tends to rotate in the anti-clockwise direction about the point B. That will be Vk into the total distances 4.5 plus 4.5 plus 4.5, which will be 13.5. Next, regarding this 20 kilonewton, so this tends to rotate in the clockwise direction about the point B. So that value will be minus 20 into the distances from here to here. That is 4.5 plus 4.5, 9. Next, moving on with this 20 kilonewton force. So this also tends to rotate in the clockwise direction about the point B. So that value will be minus 20 into the perpendicular distances, this one. That is 4.5 alone. Right. The final thing is that 36 kilonewton, the line of action is not passing through the point B. Therefore, this also will create a moment about the point B. So that nature will tends to rotate in this direction about the point B. That is a anti-clockwise direction. So that value will be a positive one. So 36 into the vertical distance between A and B is 2.4. So 36 into 2.4. That's it. Now you can see that Vk into 13.5 is been taken, minus 20 into 9 has been taken, minus 20 into 4.5 has been taken, as well as 36 into 2.4 is equal to 0. Now solving this one, we can get the value of Vk as 13.6 kilonewton. Substituting in this equation, we'll get the Vb as 26.4 kilonewton. So we got the support reactions. Next thing is we need to find the member forces. Here 1, 2, 3. These three only been asked. That is AD, CD and CE. So we are going to assume a section in such a way that will be passing through these three members directly. I just consider it a vertical. It can be provided like this in order to pass through the center of the members. Right. Anywhere we can cut it, that doesn't matter. Right. So now we are cutting this section and we are going to isolate the left portion of this segment. That is what has been shown here. So we have this AD, CD and CE members being broken members. So once it has been broken in the sense, the internal member forces will be exposed. That is, all the members, let me assume it is in tension, so that the forces will be acting away from the joint. We can have FAD and then we have FCD and then we have FCE. So these three are the member forces which are acting through this broken pieces. Right. So next thing is that I need to apply the equilibrium equation. That is what we are supposed to do in this next case. Right. So let me go with the moment about the point C is equal to 0. As I told, you can take moment about any of the points, any of the joints, because all the joints are connected by means of frictionless pins. Pins in the sense moment is equal to 0. Why I am taking with respect to point C is already two members are acted with respect to point C. Therefore, we have only one unknown will be there. That can be solved directly. That is the reason first we are starting with a moment and we are taking with respect to point C. For example, if I'm taking with respect to point B in the sense, this will not create moment, whereas this will create moment, this will create a moment, and this will create a moment. So this will not create because it will pass through this one. So that is the case means we'll have two unknowns will be there. We can't able to solve for the unknown. That is the reason we are taking moment about the point C. Okay. So now 36 will create a moment because 36, this is the line of action. So 36 will tend to rotate in the anti-clockwise direction about the point C. So in that case, this distance is how much? Between A and C vertically, it is 1.2 meter. So in that case, it will be 36 into 1.2. Now, this 26.4, that is VB also will tends to create moment about the point C. So it will tends to rotate in the clockwise direction. So that vertical horizontal distances from B to C horizontally. Total is from B to D is 4.5. Half of this distance will be 2.25 meter. Therefore, the moment created by this 26.4 will be minus 26.4 into 2.25. Again, these two will not create any moment, whereas this will create a moment. This will tends to rotate in this direction. That is a clockwise direction. That also will create a negative one. So minus FAD into the vertical distance between these. That is again 1.2. So 1.2. That's it. Now we can use this one. You can see 36 into 1.2 has been taken, minus FAD into 1.2 has been taken, and minus 26.4 into 2.25 is also been taken. So solving this one, we'll get the value of FAD. So the first question is over. That is the member force in AD, which comes to be minus 13.5 kilonewton, which means the assumed direction is wrong. This will be acting in the opposite direction, that is in compression. So AD is in compression. 13.5 kilonewton. Next, I can apply the horizontal and the vertical force equilibrium. Let me go with the horizontal force equilibrium. Fx equal to 0. So in that case, you can see that these both are inclined forces. So we need to find the included angle between these two. That is, we can see if I am taking a triangle like this, both anywhere we can take. Let me assume in order to reduce the complexity, I can put a triangle in this way. This is same. This is theta. So opposite side is this one, adjacent side is this one. So opposite side is half of this 2.4, that is theta is equal to tan inverse of 1.2 is the vertical, horizontal is half of this 4.5, this is 2.25. Right, so that will be getting the theta value as 28.07 degree. So now this value can be applied anywhere. So this is what is theta, and this is also theta, equally inclined. Right. So now if we are solving, we can see that FAD is acting. It has been assumed, don't change the direction as of now. It has been assumed to be acting in the right side direction. But the value what we got is minus 13.5. So FAD will create 13.5 in the X direction. Now moving on with this one, this FCD will be acting in this direction. That is FCD cos theta. Positive will be there. And similarly, rotating this FCE along the x-axis, that is also acting towards the right side direction. That is FCE cos theta. That's it. This will not create any moment, whereas this one is a left side one. So minus 36. So that's what has been taken. So minus 36 and then minus 13.5 plus FCD cos theta plus FE CE cos theta, which will be equal to 0. Right. So now you can see that we have two unknowns. We can't able to solve. So keep it as such. Next, we can move with the vertical force equilibrium. So in that case, we have this one 26.4 kilonewton is there. And then we have the vertical component of these two. This will be acting in the upward direction. So FCD will be acting, let me draw it here. FCD will be acting in the upward direction, which will have the value FCD sine theta. Similarly, FEE tends to have the vertical component in the downward direction. That value will be FCE sine theta, downward direction. So it will be negative. So this one, and this one will be taken into account for the vertical force equilibrium. So that we'll have upward 26.4, upward FCD sine theta, downward FCE sine theta. Right. Now we can see that we have two simultaneously equations. Let this be 1, let this be 2. Two simultaneous equations with the two unknowns of FCD and FCE. So solving these two simultaneous equation, we can get the value of FCD as 0, which means that this member is a zero force member, which has been introduced only to improve the stability of the structure. And then FCE is being solved as 56.1 kilonewton, which is in tension, which means the assumed direction is correct. So now we got this one. The AD member is a compression member. Let me erase those things, other things. Right. So this member is a compression member, which is having a value of 13.5 kilonewton. And CD member is a zero force member, which will not have any values. And CE member is in tension, which values of 56.1 kilonewton. This is what has been asked. These three members only has been asked to find out. Okay. Thank you.